Okay, so this is part 2 of the Arrhenius equation example, and I was just explaining that we can simplify these two equations and remove the term natural log A by subtracting one from the other. So we'll just write that down. Subtract one from the other. To remove the term natural log A. Okay, so we end up, the largest value is this one. So we'll go natural log of 4.5 times 10 to the power of negative 10, and we'll subtract the other one. That's the natural log 1.3 times 10 to the power of negative 11, and that's equal to, so that was, we were subtracting, so the bottom one, so that would be negative EA over 8.314 times the temperature, and then we'd be subtracting our negative EA up here. So we're subtracting a negative, so we'll just say we're adding Okay, remember the whole point of this is we're trying to isolate EA, the activation energy, so we can find out what it is. Alright, so the next thing we want to do, well, we've got 8.314 in the denominator here. If we multiply everything by 8.314, we could cross that off. So let's do that. We're multiplying everything by 8.314. So that means over here, 8.314 multiplying the left side by 8.314, and over here we multiply both of these terms by 8.314. It's just going to result in that canceling. Okay, so we're getting there. The next thing we want to do on the right side is find a common denominator. So if we multiply this top and bottom by 543, and then if we multiply over here, we multiply both top and bottom by 623. Remember, whatever we do to the bottom, we have to do to the top. I learned that back in grade 9 or 10. Okay, so here we have a common denominator, and so at this point, it's getting a bit messy, so let's rewrite this. We've got 8.314 equals, okay, now I'm just gonna, I always like to have the positive value first, so I'm just gonna switch these two terms around. So we've got, and I'll write it as 623 times the activation energy minus 543 times the activation energy over our common denominator of 623 times 543. Okay, we're getting there. In the next video we'll get rid of that denominator and we'll isolate the activation energy.